What if everything you see, the stars, the planets, the galaxies, was just the tip of the iceberg? What if 85% of the entire universe was completely invisible, hidden in plain sight? This isn't science fiction. It's the greatest hunt in human history. A search that has already cost billions of dollars and challenges everything we know about reality. What is this dark matter? Why can't we see it? And the most terrifying question of all, what happens when we finally discover what the universe is hiding? Stick with us to find out. The story of this hunt begins in the 1970s with an astronomer named Vera Rubin. She was observing distant galaxies, expecting to see the stars at the edges spinning more slowly than the stars in the center, just like how Pluto moves slower than Mercury in our solar system. It's basic gravitational physics, but that's not what she saw. To her astonishment, the stars at the edges of galaxies were moving way too fast. So fast that the gravity from all the visible matter, all the stars, gas, and dust combined, wouldn't be nearly strong enough to keep them in orbit. The galaxies should have been tearing themselves apart, flinging their stars into the empty void of space. But they weren't. They were perfectly intact. There was only one possible explanation. There had to be something else, something invisible, but with immense mass, whose extra gravity was holding everything together. A dark matter. This wasn't some small anomaly. Vera Rubin's calculations suggested that this invisible matter was 5 to 6 times more abundant than normal matter. Since then, other evidence has piled up. We see the light from distant galaxies being bent and warped as it passes by massive clusters, an effect called gravitational lensing. The problem is, the distortion is far greater than the visible matter could possibly cause. It's like seeing the image of a spoon bend in a glass of water, except there's no water there. The only explanation is the presence of a gigantic invisible mass, dark matter. So think about that. The force keeping our own galaxy, the Milky Way, from flying apart comes from something we've never seen. It governs the fate of the cosmos, but it doesn't interact with light. It doesn't reflect, emit, or absorb it. It's a cosmic ghost on an unimaginable scale. This leads us to the fundamental question that consumes physicists today. If it's everywhere, why can't we find it? And how are we trying to hunt this ghost? To find something, you first need to know what you're looking for. And in the case of dark matter, it's easier to start by figuring out what it isn't. Could it just be dust and gas that we can't see? Nope. Even dark clouds of dust would block the light from stars behind them, and we don't see that happening on the necessary scale. Could it be black holes? Or cold, dead stars? Astronomers are pretty good at calculating the mass of those objects, and even if you add them all up, it doesn't even come close to the amount of missing mass. Dark matter is something else entirely, something that isn't part of what we call normal matter. This means dark matter is likely made of a type of subatomic particle we haven't discovered yet. A particle that doesn't interact with the electromagnetic force, the force responsible for light. It only seems to interact, as far as we can tell, through gravity. That's why it's so shy and hard to detect. And this is where the billion-dollar hunt really begins. Scientists are attacking this problem from 3 different angles, in one of the most complex and important searches of all time. The first line of attack is direct detection. Deep in abandoned gold mines, over a mile underground, scientists build ultra-clean laboratories. They go this deep to use the Earth itself as a shield, blocking the constant rain of cosmic particles that bombard the surface and could create a false positive. In these labs, they build giant tanks filled with supercooled elements, like liquid xenon. The idea is that with billions of dark matter particles passing through the Earth every second, one of them, just one, might eventually collide with the nucleus of a xenon atom. This tiny collision would release a nearly imperceptible flash of light, which would be picked up by extremely sensitive sensors. Finding that flash would be like hearing a single raindrop in the middle of a hurricane, but if we manage it, we will have finally seen dark matter. The second strategy is indirect detection. If we can't see dark matter directly, maybe we can see what happens when it destroys itself. Some theories predict that when 2 dark matter particles collide, they annihilate each other, producing a fireworks display of particles we can see, like gamma rays. So, space telescopes like NASA's Fermi Gamma Ray Space Telescope are constantly staring at the center of our galaxy and other areas where dark matter should be dense, looking for this excess of gamma rays. It's a search for a signature, a cosmic crime scene that proves dark matter is there. Finally, the third approach is the most audacious, creating dark matter right here on Earth. At the Large Hadron Collider, or LHC, in Switzerland, physicists accelerate protons to nearly the speed of light and smash them together. Einstein's famous equation, E=mc² tells us that energy can be converted into mass. By creating collisions with immense energy, scientists hope to, for a split second, produce new particles. The hope is that among the particles created, there will be dark matter particles. Since they'd be invisible, we wouldn't see them in the detectors. But they would carry energy and momentum away from the collision. So, scientists look for collisions where energy disappears. If the energy before the collision doesn't match the energy after, that missing energy could be the proof that an invisible, phantom particle was created and escaped. So far, after decades of searching and billions of dollars invested across these three fronts, the result has been a deep, mysterious silence. We haven't found anything definitive. And that silence is starting to make scientists nervous. It forces us to ask, are we looking in the right way? Or is dark matter something even stranger and more revolutionary than we imagined? So, here we are, in the middle of the greatest hunt in history, with the most sensitive detectors ever built, and the universe remains silent. This silence brings us back to our original questions, but now with a new and profound urgency. What is this dark matter? The honest, and perhaps most exciting truth, is that we still don't know. The fact that we haven't found it where we expected to suggests it might be far more complex than a simple shy particle. Some scientists now wonder if dark matter isn't a single substance, but a whole dark sector of the universe, with its own particles. Maybe even its own forces of nature, a shadow echo of our own visible world. Others dare to ask an even more radical question. What if there is no dark matter? What if the reason galaxies spin so fast isn't because of some invisible mass, but because our understanding of gravity, Einstein's theory, that is the bedrock of modern cosmology, is incomplete? Maybe gravity just works differently on galactic scales. This is a controversial minority view, but the silence from the detectors makes it a possibility we can no longer ignore. And why can't we see it? The answer remains the same. Whatever it is, it lives in a world apart from our own, a world without light. It is a ghost we can only feel by its weight, the unseen force that sculpts the cosmos. This brings us to the final, most important question. What happens when we finally find it? The discovery of dark matter won't just be another piece in the puzzle. It will be a whole new puzzle. It will be the biggest revolution in physics in over a century, proving that the world we know, the standard model of particle physics, is just a tiny fraction of the true reality. Finding it could give us the key to understanding how the first galaxies formed and what the ultimate fate of the universe will be. It could open doors to a new physics that today sounds like science fiction. In the end, the billion-dollar hunt for dark matter is more than a search for a particle. It's proof of our relentless curiosity. The universe is hiding something from us. Yes, it has presented us with the perfect mystery. But every experiment we build, every theory we test, and every time we fail and try again, we learn more about the cosmos and, most importantly, about our own ability to question, to imagine, and to explore the unknown. The hunt for dark matter is the human journey itself, written in the stars. What will we do when we finally open this cosmic vault? We'll change the world. And the hunt is far from over. In fact, it's just getting interesting.